So let's start the dialogue.
Yeah. Any comments as far as the presentation is concerned? Any changes, modifications which you'd like to have?
Rashmi, I have done few, and I would like to ask some clarifications or one or two because I would like to remove one or two slides, and I have
Sure.
added few. So
Okay. Okay. So as we go through the presentation, or should we go through it once quickly and then start with the actual presentation? How would you like to go?
anything is okay.
Should I
Maybe
start?
I think now it's going to be a quick go through, right?
Yeah, I mean, basically, I'll be the moderator for this session. So, starting off with welcoming all the people who have joined. I think we have already got around 50 people who have registered, and normally more join later on. So, I expect by tomorrow we should have a good number of people joining us. So they are from different regions where our distributors are there, especially Sri Lanka, Australia, Turkey, Middle East. Uh, I think we'll be having a good gathering this time. So this is basically what we cover during all our sessions. This was the flyer which we had sent to our customers and on WhatsApp. This is like series 6, which we are doing right now. And next is series 7, where L&T, Mr. Veragi and Pradeep Chaudhary, XGE, who will be making a presentation on the mold design, etc., various aspects as far as design is concerned. Then we will be having series 8, 9, 10, 11, and 12. So I will be covering up very briefly a quick recap. Will not be going into details regarding each of the sessions. This is just a recap on the sessions which we have already done. So this is the first one. The second on the flame retardant mechanism. The third on the flammability testing, UL94 and glow wire. Then the fourth one, which was on LOI, smoke density, CTI, hot wire ignition, high current arc ignition, arc resistance, and the long-term property evaluations. Then we had a session where Pankaj Chaudhary from VDE had presented. He's head Indian operations, and Prashad Shankarappa from UL. So now we come to the present session. So this is a brief introduction. I hope this part is okay, Satish, or would you like some?
Yeah, it's well,
Okay,
fine,
so
fine, fine. It's well and
yeah. So instead of having it in 3 pages, I just consolidate it into a
yeah,
single
yeah,
one.
fine, fine, because that's our normal one which I had. So
Yeah. And this is Alexi. Alexi, you are okay with this, or you want to make any changes?
No, it is perfect. Huh?
Yeah, it's perfect.
Well,
And then this is where Alexi will start talking about the flame retardant grades with UL cards. So, Alexi, hope this slide will be covering up again because it talks about our flame retardant products. Is that okay?
yes. So I will have to comment on this one. Huh?
Yeah. From
Okay.
this year, immediately after talking about
Okay.
I'll hand over the presentation to you. So this is where we will be starting.
Okay.
So, would you like to say something, Alexi, on this, or any
No,
changes,
just
modifications?
no. I think I will. I can manage. No problem.
Okay. Then this is on processing FR compounds, care
Mm-hmm.
and guidelines. So here we briefly mentioned the star flame P series and the star flame R series. What are the processing temperatures for the star flame grades? Then proper drying is important.
Mm-hmm.
Drying conditions. Then processing FR compounds, melt temperature, back pressure, screw recovery, and residence time. Then purging, purge puddle, and material changeover. Actually, this part is very critical in terms of when we are using a flame retardant compound, it's very important to purge and clean the machine, especially when we are stopping overnight or for a longer duration. Then part handling, then regrind handling. So this is for part handling, like when parts are directly out of the molding machine, they're still warm and can emit vapors during the cooling. So we should allow cooling and not package them immediately out of the mold. So you want to add any other points on this, Alexei?
No, I will just make some comments during the presentation, but okay, nothing especially to be written down. Oh, it's great.
Yeah, only we'll be adding a few pictures over here. So because these slides don't have pictures, so we'll be adding a few pictures on these slides.
Okay, if you have.
So regrind handling. And then we come to tooling considerations.
Yeah.
Basically to minimize the corrosive effects. And then hot runners, sizing and temperature control. Then some tips for success. Occupational exposure limits, short-term overexposure effects, long-term overexposure effects.
Okay.
And then you will be talking about all the halogen and non-halogen systems. So starting with the red phosphorus based system. Then organic phosphorus. Then halogen-based systems with the synergists. Then metal-based FR systems. Nitrogen-based systems. And this is like, you want to keep this slide? Should I let it be or?
It helps in a transition, let's say, maybe to the next, or maybe just before the pages detailing the spatial handling by family. You know, before the red phosphorus page, just to explain that we have so many difference, and then we can go through maybe. But it's okay. It's okay for me to. It also depends on the transition you want to make.
After this, we want to have that slide.
Yeah, maybe. So it makes a transition. Let's say we discussed about general matters, and now there is very specific things to specific systems. So depending on the time, we can pass a few seconds on explaining what are the systems and what are the specific concern you have for each systems. But it's up to you. I can manage.
Okay. Any of these slides you want to add anything else?
No. I think it's yeah, it's really okay.
So this will be your last slide.
Yes. I think it's already a lot for 20 minutes.
Yeah. Satish, now over to you.
Yeah, can I share my screen?
Yeah, I think that will be better because I think you made some changes.
Yes, and then once we finalize now, I'll try to send you the latest one.
Yeah, so I have, you can share your screen now.
It's okay, you can see my screen?
Yes.
Yeah, If you can put it on slideshow, it will be
Yes,
better.
yes, yes. I'm just coming to that. It's okay, right? It's on the slideshow.
Perfect.
Yeah.
Okay.
Yes.
So anyway, so I'm starting with this because since we talk about process, and when we talk about CPK or the process capability, I thought I'll start with this, mentioning or just to give a reminder on the different parameters or the different things that need to be considered for the part quality. And then just a reminder on the main important criteria or the things that need to be taken care. And then the last one, when we talk about molding process, I will talk about the control and consistency, the repeatability, and then a few information on the CPK and the process, and then the performance capability. Then I will try to give more detail on PPAP. Rashmi, I have left the slides, what you have prepared to, which will come next. But I have given a little more information on CP and CPK, where here I have slightly given a detailed or slight more detail about where the CP talks about only shot to shot, not about real the variation based on the centric value or the tolerance of what it could be as per Six Sigma, and then CPK, and then its benefits or how to manage it, and then this is what you have done. So I'm going to keep this, and then here I'll emphasize that mostly for new product or new part development, anybody has to concentrate more on CPK rather than PP or PPK, because PPK is more on the historical process or performance of a specific, I would say even at industrial level, but at part level, they have to concentrate more on CPK. This is same.
Would you be covering like in the shift, what are your considerations? Would you be having that part also? Like
I have not,
for a particular.
No, I have not included here, but in the shift, in the sense, what kind of things you mean to?
Yeah, what are critical parameters which have to be taken into consideration for a single shift? One is like long term, the other is short term, like for a particular shift, what are the parameters which you look at and which are critical for performance?
Okay, let me check, because that will take a long time, or again more things need to be added. Okay, let me see.
No, I mean, just like if you can just briefly touch upon it, I think that should also be good enough.
Fine, because PPAP will cover a few things. Let me show you. Oh, okay, so this is what you have given. I'm going to keep this, and then I'm coming to PPAP.
Okay.
Okay, so PPAP, there are anyway 5 level of process, and then a minimum of 18 different things, or I would say 18 documents which need to be managed. So I will talk about that here. Generally, what is PPAP and what are the different levels, documentations required. And again, whatever I told on the 18 points that need to be taken care in PPAP. So normally, even this, whatever we talk here, this will take care of what need to be taken care even in the shift also.
Yeah, I think, this covers up.
Yes, so it's about this will completely cover from, for example, if I am giving an outsourcing, or even if I'm going to start a molding with any of my vendor, from design documentation to engineering change, the customer engineering approval, DFMEA, PFMEA, the process flow diagram is from molding process to, even if there are sub-assemblies at product level, the complete process flow diagram. PFMEA, then the control plan is again an output of PFMEA. So this will cover different aspects about the first article inspection report. When I say measurement system, it's about the complete R&R calibration records of lab. So this will talk about all those points. Probably I think this is what normally is getting covered in shifts. But anyway, these are the different documentations where even they will try to keep in shifts from one shift to another, or a documentation that they have to maintain at part level or at a molding shift level. So this is sufficient?
Yeah, I think only like sing off, you'll have to put it as sign off. I think it's sign off.
Yeah, okay. Yes.
Yeah.
I'll correct it.
Yeah, I think this covers up.
Yes.
Yes. Okay, Alexi, anything else you would like to, because here I will stop about process capability or PPAP because
No, it's already a lot. It's nice. Yes. No, it's perfect.
okay. And now straight away I'll come to the injection molding process and troubleshooting. Here I'll try to explain in very brief the injection molding process because I'm assuming all the participants will definitely know the process. So I'll just touch upon the entire cycle and then I'll go next. Rashmi, probably here I would like to remove the slide in case if there is nothing
Yeah,
specific.
I think we can remove it.
Yeah, because even the different things we listed, it's not exactly in concern in respect with the machine specification, because we talk about feed system or multi-cavity mold or the importance of adequate venting. So there are different points. So
Yeah, I think we can remove this.
yeah, so I'll remove this slide.
Yeah, we'll remove this slide.
Yeah, and this slide
Yeah.
too.
Okay.
Yeah, and then we can straight away start with
Okay, so
different
these.
molding. Yeah.
Mm-hmm.
These two slides, and then we can straight away talk with start with different molding defects. So I'll try to give a brief on each sink mark, entrapment. Yes, here I don't know, the entire thing is going to be little you will see in each
So you don't have to.
Hello.
Yeah, we lost you, Rashmi.
Rashmi, we lost you. Okay, so Alexia, I was just trying that this will be little boring for participant because you know, right, in each sometimes in each defect there will be some repeated point, because everywhere there will be melt temperature, pressure, injection pressure, mold temperature. So I will not spend too much time on each defect, but I'll main points I will try to highlight on each one.
Yes, I think.
Yeah,
Yeah.
critical. Yeah,
Yes.
critical points you can highlight and then leave out the rest.
Yes, so just here I have added a few. I'll especially for glass because just based on my experience, because in Schneider or even with many industry whomever I interact, everybody wanted to know why there is glass fiber coming onto the surface, why always, and then how it's related to mold temperature. So I used to take a lot of training, and then I used to include these slides in case if you feel it's too much or it's not really necessary, then I can take it off. Just
No, it's good. I think this
yeah,
because
great,
this is
yes.
like practical.
Just to give them an understanding of the fountain flow or the flow front, the velocity profile, how the melt flows inside the thickness. Here I'll try to explain. I'll not spend too much time, but I'll try to run very brief, just to show them how the fountain flow and then how really a flow front joins. And in case if the previous one is, for example, this is a case where an unfilled material will look like. And if you take a glass filled material in the joining area, this is how it will look like, just to show them even the melt joining area. And then in brief, this animation is to show them in case if we consider even this as a polymer molecule or even glass fiber, if we consider a single fiber under this, considering this velocity profile, a fiber can have a different velocity profile from one end to another end. And this is how it may tend to flow inside the mold wall. I'm taking a single fiber and trying to explain how it may pass through the mold wall and then get aligned. And just to tell them that this is why we have a real issue on warpage or differential orientation on the component with compressive or tensile internal stresses. And the fibers which is getting oriented here is what we will see on the part surface.
Yeah.
So
Yeah, I think
only to give a brief on that, to show them again this too. So this is okay, or do you feel it's going to be too much on the to discuss on the troubleshooting, or you feel it's okay?
No, it's okay. I think it covers up one critical aspects and it covers up thoroughly.
Okay, fine. And then I continue with the defects. Okay, this is just to show when I finish well line, just to show them the flow and well line, just a small animation there. Anyway, it's jetting and diesel effects. This I will cover. Short, I have just one animation. These are animations which I use in our internal trainings. I have tried pulling up that to show them if you have a wrong getting location, and even if you have thin walled with tall ribs, how the flow will be, the back flow, and then sometimes the frozen layers, the material will freeze here even before it reaches the part end. This is just to highlight that. Continue with this. And here when I talk about deformation, especially warpage, I am trying to show this animation which will explain or talk about simply the varying thickness. So when we have uniform thickness, gradually varying and then drastically varying thickness like this, how really the material flows and then how is the effect on the warpage. Here to show it's completely symmetric. Here it is asymmetric up to a certain level where you can see that the warpage is not really too high. But here, though the value is only a 0.1 or 0.2, but it is completely asymmetric. So this is to show that. Is this okay?
Yeah, I think.
Perfect, yeah.
Okay. This is again to show. Okay, I need to remove this because I have copied this there. Okay, so that's it. Because we are coming to the end of the presentation here. And Rashmi, this one, do we really need?
No, if you feel I'm fine, because this like covers up the entire thing in one shot. Like just if there is jetting, then you increase the cylinder melt temperature, injection speed is reduced, nozzle temperature is increased by 1 degree, mold temperature can be increased by 4 degrees. So it's like something very basic in terms of point wise we mentioned.
Yeah,
but if you
so,
because it will take a lot of time.
We can show this and then we can tell them they can go through
Yeah,
this reference.
they can go through it. Yeah.
Fine.
So I think this will be the last slide.
Yes, and that's the modification I have done, and then I'll send you right after this, and then you can combine all together in one.
Sure.
And in case if you have any comments, you can tell me now. Which I'll try to modify and then send.
No, I think it covers up well. So only like last slide, what you want to keep, that basically you can decide.
Fine.
And we'll have a question answer session, say around 5-10 minutes. And I think I'll just share this thing. So I'll make the necessary changes, maybe reduce a little bit text across the board.
I think the text is means here the text is okay. I think when we explain, we will manage, no issues.
Yeah, we don't have to read everything, but I think the text is okay, yes.
Yeah, key points which you feel important, you can discuss those and the text as such.
Yes. I think don't spend again too much of time on this.
Yeah.
You can leave as it is, and then when we explain, we will explain or we will try to point out only the important things. No?
Yeah. Because we'll be like having around 40 minutes, 45 minutes for the presentation and something around 10 minutes for the question answer session. Then I think we'll have the question answers, and I don't know if this is required, we can see. Just talking about some of the star flame and form poly grades. And then the next session, which we will be having on design perspective. And that's it. So that's how the presentation flow will be.
Fine.
So, okay.
Yes. No, I think it's very okay, and it's not so much so often you can have all this information gathered somewhere. So at least we will have in our computers, and we can use it or explain. It's a nice frame, I think. Yes, it's a very nice frame.
Yeah, so good. So looks good. Tomorrow,
Yeah.
I think we'll start at around 2:30 India time.
Yes.
And so that there are no hiccups for joining.
Fine.
And I think it should be over in roughly 1 hour's time from 3 to 4.
Hmm?
So anything else, any changes, any other modifications apart from what we have discussed?
No, no,
I'll
no.
wait. Yeah,
For me, it's
I'll wait
perfect.
for yours, Satish, and
Yes.
Alexi. You are okay with the first slide? You'd like to start with that or some?
Yeah. Just need to know where do I start exactly, but once I know, I can manage. It's really no problem. Yes, it's a nice introduction. Yes, yeah.
Yeah, this
To
is where
explain
you
that, yeah.
start, and this is like the second slide where you talk about star flame and
Yes.
so then certain parameters which are critical
Yeah.
for flame retardants. And then we go directly to the halogens and the non-halogen, various FR systems.
Yes. I think yeah.
Yeah, and this you want me to shift or should I keep it here? I'll shift it to immediately before you start with the halogen and
Yes, maybe just before the red phosphorus page.
yeah.
So it would be easier to make a transition between general stuff and very specific to Starflam, and explain that there are some special care linked to a special type of flame retardant, and scroll down a few of them, and it will be perfect.
Okay.
Yeah.
And Satish, you would start from the slides which you have added. So I think that should be okay. So,
Yes, fine. I'm going to send you the slides right away in few minutes.
yeah, so I'll just consolidate the whole thing and share it with both of you.
Yes. Fine.
So, okay, so it looks good.
Yes, really good. Yes.
Okay, then.
Okay, Rashmi, thank
Yeah.
you. So you will
you.
get it in another 5 to 10 minutes max, because I
Sure.
just need to delete and then just small editing, and then I'm sending you.
Yeah, sure. Thanks. Thanks for joining.
Okay, thanks so much, and looking forward to tomorrow.
Yeah.
Okay, bye.
Okay,
Bye-bye.
bye-bye.